Alright, so we're going to look at some more examples of graphs and how we get the limits. So for part A, it says the limit as x approaches -3, and because we have that negative sign there, that means from the left. Alright, so we're going to find our x value of -3, which is here. Well, we have a vertical asymptote of -3. So, as we approach -3 from the left, we're going to use this graph. It's getting closer and closer to that asymptote, but the y values, which is what we care about, keep going up forever. They keep getting bigger and bigger. So they're going to be approaching infinity. It's going to be equal to infinity. Okay? Part B. The limit as x approaches -5. It doesn't say left or right, it just says -5. So if it just says a number, you have to make sure you check the left and the right. So here's -5. We have a hole and we have a place where it's defined a point. So what we're going to do on the graph, if we come in from the left, the y value that we approach at -5 is 4. If we come in from the right side, the y value that we approach is 4. So when you come in from the left and when you come in from the right, even though it's a hole, you're still approaching that y value of 4. So because the left and right are the same and it's a real number, that limit exists and gives us 4. Alright, part C says the limit as x approaches -1. Alright, so same thing. We're going to find -1, which is here. We got to come in from the left and the right and make sure they're the same number and a real number. So if we come in from the left, the y value that it's approaching is -1. We come in from the right, the y value that it's approaching is -1. So from the left and right, they both give you -1, which is a real number. Alright, for parts, here's another part C. Part C2. The limit as x approaches -3. So we did look at -3 earlier. It was here. Okay. We do have that vertical asymptote, so that should be throwing us off a little bit. But when we come in from the left, it approaches infinity, because it keeps going up forever. And when you approach from the right, it gives you negative infinity. So not only are those not the same thing, but remember those are not real numbers, and your limit can't exist if it's not left or right. It's not a real number. So this does not exist. And it wants us to tell why. So we're going to say because the limit as x approaches -3 from the left of f of x, and the limit as x approaches -3 from the right of f of x are not real numbers. Okay, so just, it's a clue when you have a vertical asymptote that you need to be wary of that. Alright, part D, the limit as x approaches 2, and it does have the little negative sign, so from the left. Alright, so if we find 2, we're coming in from the left, so we're going to use this graph. So if we come in from the left, it's going to approach that y value of 1. Sorry about that. So next off, we're looking at the limit as x approaches 2 from the right, because it has the plus. So same, we're still looking at 2, which is here, but this time we're coming in from the right, so we have to use this graph. So if you come in from the right, as you get closer and closer to x equals 2, the y value is 6 there. So, when we get down here to part F, it says the limit as x approaches 2. Well, remember, to do the limit, you have to check the left and the right. Well, we already checked the left was 1 and the right was 6. So, remember, if they're not the same, then it doesn't exist. So, since we have to give a reason for this, we would say because the limit as x approaches 2 from the left is not equal to the limit as x approaches 2 from the right. They were real numbers, but they weren't the same real number. Alright, and then part G, the limit as x approaches negative infinity. So guys, when it says x is infinity or negative infinity, they're talking about the end behavior. So they're really referring to the left end behavior here. Okay, so left end behavior just means what's the left side of the graph doing. So if you go to the left side of the graph, The x's are getting smaller. The y's are getting closer and closer to this horizontal asymptote, which is at 2. So this is going to be equal to 2, which is actually a horizontal asymptote. So then it says the limit as x approaches infinity. So this is talking about that right in behavior. So we're looking at the right side of the graph. So on the right side of the graph here, well, this graph keeps going up and up and up, and the y's keep getting bigger and bigger and bigger. So this one's going to approach infinity. Okay? So we have another set to look at. Change the graph. So same kind of thing. We have a graph, different graph, but same type of question. So if the limit doesn't exist, we have to explain why. So let me do this. That's a little easier to read. Alright, so part A, it says the limit as x approaches, this is a -3 from the left. Okay, so if we find -3 on the graph, it's here. We're coming in just from the left. So if we come in from the left side, as we approach -3, the y value that it's getting closer and closer to is 0. And it's just the left side, so you don't have to check that. Alright, part B says the limit as x approaches -6. Now this is not the left or right, so you've got to check both. So if we go to -6, well here's -6. Okay, now if you notice the graph's continuous there, so it shouldn't be anything weird, but if we come in from the left, the y value is -4. If we come in from the right, the y value is -4. So because they are both -4, then the limit as x approaches -6 is that just that point -4. Alright, part C says the limit as x approaches -1 from the right. So let's go to -1, which is here. We're coming in from the right. So if we come in from the right, as we get closer and closer to that x equals -1, the y value that we reach is 2. Alright, part D, the limit as x approaches -3 from the right. Okay, so -3, which is here, from the right side. So we're going to go from the right, and that y value is still 0 there. Alright, part E says the limit as x approaches 4 from the left. So if we find 4, so 4 has this vertical asymptote at it, and we're coming in from the left side. So coming in from the left, so this graph does not keep going. Okay, these y values are not keeping smaller and smaller. These y values actually stop here. So this graph doesn't even get close to this x equals 4. So this doesn't exist. But then the reason in here is because g of x doesn't approach 4 from the left. Okay, it's not getting closer and closer to that 4. It doesn't even, it stops. Okay, so because this doesn't keep going, you can't get an answer there because it doesn't even get close to 4. Alright, for F, it says the limit as x approaches 4, but this time we're from the right. Okay, so 4 from the right. Alright, now this has an arrow. It does keep going. So the y values as you approach 4 are getting smaller and smaller and smaller. So this one approaches -infinity. So I want to make sure you can see the difference between these two graphs. This graph stops, so it's not technically getting closer to 4. This graph keeps going forever, and as it gets closer to 4, the y values get smaller. Okay. So then ask about part G, the limit as x approaches 4. Well, you've already looked at the left and you've already looked at the right. Are they the same thing? No, one of them already didn't exist. So this doesn't exist. And if you have to give it a reason, because the limit as x approaches 4 from the left is not equal to the limit as x approaches 4 from the right. Okay, one of them was already does not exist. And then for part H, the limit as x approaches -4 from the right. So -4, which is here, from the right side would be here, As you get closer and closer to x equals negative 4, the y value is about negative 2.5. And then the last one for I, the limit as x approaches negative 4 from the left. So negative 4 from the left, if you come in closer and closer to x equals negative 4, the y value there is negative 6. So there could be a next question that said the limit as x approaches negative 4. Well, because the left and the right are not equal, then we would say that doesn't exist.